make sure you've got notes and you're copying some of the annotations that I do here, because it might get a little bit confusing, but if you've at least understood the previous 3 chapters, should be okay for the most part. I think the hard thing I find with networks, especially when it comes to now bringing in new these terms, is just remembering what all the words mean. Okay, so words like isomorphic, just remember it means exactly the same thing. What else did we learn? Adjacency matrix. You know what that is. You know what a matrix is, yes. But adjacency is just representing a network, yeah. Connected graph. Okay, those words. All of this, it's gonna come up, and I think you'll find in chapter 9 F and G is when it gets a bit more confusing because there's a lot of new words that you have to remember. Okay, but let's get into it. So planar, chapter 9D. So a planar graph, okay, is something that you probably all in one way, shape, or form have seen. Now, a planar graph, according to this, is a network graph that can be drawn on a surface without any, so this is the key part here, no intersecting edges. So what that means, okay, and why it's important is, say you've got a network like this, okay. Oops. Let me add another vertex. Okay, let's just draw a network with 4 vertices. Okay, say you've got a network that looks like this, yeah? And you've got that, and then maybe you've got that, and then you've got that. If you look at this, it looks nice and pretty, yeah? But if you ever get into like engineering or any sort of job where you have to work with networks, like one job I can think of where this might apply could be if you're a train director, or if you're planning like the Melbourne train system, okay? And the reason why planar is good is because what they like with planar graphs is they want you to be able to draw a graph without any of the lines intersecting. So if I was to redraw this, it might look like this. Okay, so you've got 1, 2, and then you've got 1, 2. Now notice none of the lines cross each other. And that's important because they want to be able to see what's connected to what directly. Okay? And that's the point behind a planar graph. Just making sure that you can, or understanding if a graph can be drawn without any of the lines crossing each other. Okay? So for example, this graph here is not in planar form, but I've put it in the other graph here in planar, where none of the lines intersect. Okay, so that's what we're looking for when it comes to the word planar. None of the lines intersecting one another. So for example, which of these graphs are planar? Now you can look at it and tell me, sir, none of them are planar. Everything's intersecting. Okay, but can you get any of these graphs and draw them so that they are planar? Can anyone tell me any of these graphs? Will they be planar if I redrew them? Or can you tell me which ones could be planar? Based on what I mentioned here. Anyone know?
First one.
The first one? Okay, why the first one, Ryan? So let me redraw it for you guys. So you tell me, why is the first one planar? Let me draw the connection. So you got that, there. You got a loop. Okay, so why is the first one planar? What can you do to it?
You only have to move one of the middle ones.
Good. You got to only move one of the middle ones. Now I can move this line and just draw it this way. Now it's planar, okay? Or I could also move this line, put it here, and now it's planar, okay? So even though the first graph is not drawn in planar form, it is planar because you can put it in planar. Okay, so what you would write, actually I'll leave that there. Okay, that is technically, you can make it into a planar graph. What about the second one? Can you make that graph planar? All right, let me try and redraw it. 2, 4, 5. So I see it's sort of looped around this way. And there is an upside down star, which looks very demonic. No one got that, eh? Okay. Can you make this graph planar? Okay. Anyone do it? Is it possible? Can I rub off some of the lines and connect them around to another way so it's planar? I can try and see what happens. So for example, I might get rid of this and put it here. I might try and get rid of this and put it here. Okay, but now what happens, guys, is if I try to get rid of this line, I want to connect it here. Can I do it? Okay, I can't because I'm going to be intersecting that line, so I can't. So technically, the second graph is not planar, okay? If you try to redraw it. Second graph cannot be made into a planar graph. There's too many lines happening, basically, yeah? So you can't make it into that. What about the last one? Is the last one planar? This one might take a little bit more work to figure out. So let's draw the vertices and the edges for it. Okay, the connections are, so that's connected, that goes here, there, and then you've got two going this way. Okay, can I make this graph planar? Is it possible? Okay, well, I think you could, but you might have to move a couple lines here and there. Okay, it is possible. So what you could do is you could move, let's see, what could I move here? Remember I did this in my head just before. You could move this line here. Okay, and what else could you move to make it planar? There's one more line you can move. The other line here. So you can move this and put it here. So now it's planar. See, none of the edges intersect with one another. Okay, that is the aim when it comes to this. So that means this graph is planar. Even though it's not drawn in planar form, what you find in the SAC is you might not draw it, but you've got to try and prove that it is. Okay, so just watch out for that. Okay, so the next question is basically now asking us to draw these in planar. But before we get into that, understand a couple things, yeah? There's a couple of things you need to look at when you're working with a planar graph, okay? So now that you've drawn a graph planar, so now that we've made it like this, okay, let me put a cross here because it's not planar. Oh, that's confusing. Not planar, yeah? Remember, the aim is to make it so that none of the lines cross each other. That's what you want, which is making it into a planar graph. So now when you've made it a planar where the lines do not intersect or the edges do not intersect, okay, what happens is it divides the graph into a specific way so that now you've got what you call faces. Okay, so what are these faces? The faces are basically, if you were to look at the graph, look at the number of enclosed spaces. But here's a tricky part as well. When it comes to faces, you have to include the outside of the graph. Okay, so for example, in this graph here, okay, before you can do this, make sure your graph is planar. In this graph, this one will have 1 as the outside, 2 and 3. Or you could just count it as 1, 2, and then I do the outside as last. This has 3 faces. Okay, it's already drawn in planar, so I don't have to do anything. Let's do the other one, number 2. Now, a lot of you guys, and I've seen this in a SAC before, kids will go, oh yeah, so this has 1, 2, 3, 4, 5, 6, 7 faces. Now, why is this wrong though? Why is it not 7? It's not planar yet. So let's draw it into a planar form. Thank you, Anthony. Okay, let's do that. So vertex there, vertex here, there, and there. Okay. All right, so I'm going to copy it as is for now, and then I'll redraw the lines so that it's planar form. There, there. Okay, this has a lot happening. Okay, so how do I redraw this so that it now becomes planar? So you might have to rub out some lines, might have to move some things. Yes. Did I draw an extra line? Did I miss one?
On the right.
Oh, sorry. Didn't see that. Thank you. Okay, what can I move? Okay, I can probably move, let's see. I can probably move this one, put it out here. Okay, what else can I move? There's one more line I can move. The other one, good. This one, bring it here. And now I can count all the faces in there, yeah? So Remember, we said that there was 7 initially, but actually there's 1, 2, 3, 4, and then 5 for the outside. So there's 5 faces, not 7. Okay, so you watch out for that because it will come up in the sack. I've seen it happen before. Make sure it's planar form first. To draw it in planar. All right, last one. This one is a bit tricky, so I might move it around a little bit so it works a bit better. But essentially, there. Annoying thing is sometimes you might actually have to cut and paste or like move some of the drawing a little bit to be able to do it properly. You've got there, there, there. Okay, so you've got these guys being connected. And I know my drawings aren't that great, I'm sorry. That's connected there. Okay, can anyone see a really simple way of doing this one? Instead of redraw, I might have to redraw a little bit, but what can I move around? Yes, Anthony.
Move those, the 2 lines going to the middle, between the outside.
Which one? So are you saying
It's like the 2 long lines that are going.
these ones?
Yeah.
Yep.
Just move them 2 to go around.
Okay, you could, but watch out for what happens here though. Look at that one. So I've got that. I could do that. Okay, what about that middle one? It's not connected anymore.
Can't you just draw it into the
Is it, you mean this? You could do that. Another way I was looking at, but let me see if this works. So how many faces do we have? We've got 1, 2. Technically, that now is not enclosed, so there's only 3 faces if you include the outside. Let me test it the other way though. The way that I was thinking of it, I'm not saying you're wrong, but let me see if this other way was working as well. What I was thinking of, back, okay, was actually just getting all of this, so these 3 here, and bringing them down here. Okay, so rearranging it like this. So
you are allowed to rearrange like
you can, as long as the connections are still the same. Okay, that's what matters. So remember we had 3 faces, and I think we're going to achieve the same thing, Anthony. Crap, I forgot what it looked like. Sorry. Okay, so these 3 are connected. So let's bring this down. So technically what I was talking about was doing it like this. There, 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 and then there. You can technically do it that way too. I think the beauty of networks is, so what Anthony did was also correct. You can now have 1, 2, and then 3 faces on the outside. Correct, yeah. All that matters. So I think the hard part for me as a teacher is I have to look at your drawing properly and then actually count. All right, he's done it correctly. But as long as, again, you're adhering to the rules that we give you, okay, with these. So that will have 3 faces. All right, let's look at the last bit, and then that'll be it for the planar stuff, okay? Now, when it comes to planar graphs, there's this thing that we call Euler's theorem. So this formula here, really easy to use. Just make sure you refer back to it every now and again. You don't need to memorize it, but it's in your notes. Just make sure you look at it. So if a graph is planar, only if it's planar, okay? When you look at a graph and it's planar, you've got to make sure you can prove that a graph is planar if you use this formula, okay? So for example, if I looked at this and I wanted to prove if it was planar or not, like this graph here, I can use this formula. So it saves me from having to draw it and figure out if it is planar or not. Okay, so I use this formula here, where if you look here, V refers to the number of dots or vertices. F is the number of faces. So remember, the faces are the enclosed spaces plus the outside of the graph. Oops. And then you've got, and then you've got equals E, which is the number of edges plus 2. Okay, so let's prove this. Okay, let's prove. Let me go to this as an example to prove if something is planar or not. So V, remember let's do these ones as an example, yeah? V plus F is equal to E plus 2. Remember, V is the vertices, F is the faces, E is the edges. So in this graph, how many vertices do I have, guys, in this graph here? Let's prove that it equals what it is. So how many for this graph, guys? How many vertices? 4. How many faces? 3 equals how many edges? 1, 2, 3, 4, 5. And then plus 2. Now, let's equate this. 4 plus 3 is 7. 5 plus 2 is also 7. So that means this graph can be made planar. Okay? Let me go back to an example here and prove why that formula works. So why can't this graph work here? Okay, so V plus F equals E plus 2. I want to refer to this graph. Okay, how many vertices do we have? 5? How many faces? I don't know. Okay, I'm going to leave that as F. How many edges do I have? Let's count. 1, 2, 3, 4, 5. This is going to be confusing. 6, 7, 8, 9, 10. There's 10 edges plus 2. Now, let's solve this. What's 5 plus F? Oh, 5 plus F. Actually, according to this, I don't think it works. It's 12. It'll be 7 faces according to this. But, again, if we tried to draw a planar, it wouldn't work. Okay? Okay, I'm going to leave it at that for now, just so I don't confuse you guys. Let's just use the formula, and then that's going to be it. A graph has 5 vertices, 6 edges. Find the number of faces. Okay, so V, remember the formula? Plus F is equal to E plus 2. Okay, so according to this, you've got 5 vertices plus, we don't know the F, so we'll leave that be. It's got 6 edges though, and then plus 2. So now we need to figure out how many faces it might have. So 5 equals 6 plus F. 6 plus 2 is 8. Okay, how do I find F here? Well, I want to isolate it. So this is 5 plus F. Get rid of it here, and it becomes minus. So that means this should have 3 faces. Okay, and it's planar. B, pretty straightforward, same deal. Planar graph has 4 vertices and 7 faces. Plus 2. So in this case, 4 vertices plus 7 faces equals, we don't know the edges, so we're trying to find E. Okay, so 4 plus 7 is going to be 11 equals E plus 2. So isolate that E, this becomes minus, so that's minus 2. That means E is 9, so it's got 9 edges. You can use your CAS for this and do the solve function, but it's pretty straightforward. You don't really have to. Okay, so the main thing I think we need to get out of this part of the networks is understanding how to put a graph in planar. Planar means no intersecting lines, and you can use this formula to prove if a graph is planar or not, or finding the number of faces or edges or vertices. Yep. Okay.